Hello. Yesterday I was hoping that you got to play around with Desmos a little bit and try to, excuse me, investigate what happens when you change the function. So what we're talking about right now is this is the beginning of our graphing quadratics. This is called a parabola. The red graph is the parabola, and the function is y equals x squared. And that's what we're going to call the parent function. It's like the mama function, and we're going to learn today how, if we change or add numbers to this function, how it changes the graph. And so I need you to also have this worksheet out, or like get out a piece of paper, and we're going to write this down. It was on the back of what we did yesterday. Yesterday I was hoping that you would graph this and it showed that it was a parabola. But we're going to see what happens. This is called the parent function, y equals x squared, and we're going to go through, and if we translate or transform this by adding these numbers, how does it change the graph? So this first one is 2x squared. So this red graph is my function, and I'm just going to change this, and I'm going to put a 2 in front. And then if I press this button, it graphs it. And you can see that that blue graph is skinnier than the red graph. So adding a coefficient that's bigger than 1 is going to make the graph skinnier. If I make it a 10, it's even skinnier. If I make it a 20, the graph gets even skinnier. So the bigger the coefficient, the skinnier the graph. So let's write that down on the note sheet. If we have a coefficient like this, if the coefficient is larger than 1, and we call that a stretch, the graph gets skinnier. It's important that we know that we're calling it a vertical stretch. What that means is if I take myself and I pull myself from my head to my feet, I'm going to get taller and skinnier. That's why it's called a vertical stretch, because if you stretch it out vertically, it's going to get skinnier. Okay, so now instead of writing x squared, we're going to write 1/2. So let's add a fraction in here. 1/2 x, and then I'm going to graph it. And you can see now the function got fatter. If I change my fraction and I make it 1/6, it's even wider. Or 1/10, it's way even wider. So the smaller the fraction, the wider the graph. This is called a compression. We're taking the graph and we're smushing it down, which makes it wider. So if I push on my head, and I would end up getting wider and wider and wider as I smush. And so going back to this sheet, if the coefficient is less than 1, which means it's a fraction, we call that a compression, and the graph gets wider. And this is something that you're going to have to memorize. If I give you a function, y equals 7x, y equals 7x squared, you need to tell me, is it going to be skinnier or is it going to be fatter than the parent function? And if the coefficient was 7, bigger than 1, you would say skinnier. Okay, now we're going to add 4. Press pause whenever you need to. So coming back here, I'm going to delete my coefficient, and now I'm going to add 4. So if I turn that on, oh, what happened? It scooted up. Do you see that? Do you see how the parabola just scooted up? So adding 4 translates, which means slides the graph up. So adding 4 translates up. If you add, it moves up, translates up, or moves / slides up. Maybe you can predict what's going to happen if we do a -4. But if we -4 instead of add 4, you can see that now my vertex, this bottom point, is at -4. So if it's a minus, it's going to slide down. If it's a plus, you would slide up. We're going to pause here